Okay, so I don't know if y'all noticed what I just did. I just started a recording. I, for the last several years, have been recording all of my lectures. It's what's called a screen recorder. So it's recording what's on this screen right here, which is identical to what's on that projector screen. And then it's also recording audio. So I am legally obligated to inform you that you're being recorded. Right? That's the only reason I lead with this. You don't have to particularly care about that if you don't want to. By the way, the voice pickup is highly localized. So I'll probably pick up y'all's chatter. But it'll be drowned out by me speaking more loudly. Anyone that's more than a couple rows away, don't worry about it. In fact, even if you ask a question, it's entirely possible that it will not hear your voice very well. Right? So I might repeat, like if you ask a question, you might be too far away, so I might repeat your question just for the purposes of the recording. I'll come back and talk about the recording more in a few minutes. Okay, so welcome to Math 212, and for many of you, welcome to Duke. First college class for a lot of you, apparently. Very exciting stuff. I'm going to start with a quick comment, and that is, if you are thinking about the possibility of a math major or minor, come talk to me. There are some questions as to whether this is the right class for you to be taking. It's not the definitely wrong class, but there may be a better class. And anyway, so enough of that. If you think this might relate to you, even if you're just kind of 40-60 considering the possibility but leaning against, still come talk to me about the possible trade-offs. Okay. For those of you who are in the right class, here's the first thing that you need to know, and that is where the class website is. I cannot remember what I have emailed y'all, if anything, at this point. If I've already emailed you this link, great. Otherwise, you might want to jot this down. Or if you'd rather than jot, you can just go to the Duke Math Department webpage, go to faculty, find me. Don't click on my brother's page, by the way. We are different people. Anyway, you find me, and I have a link on my own faculty page that says something like class websites. It'll take you right here, so that's totally fine. Okay, so that class website has a lot of information on it. Let me click over to, that's not it. Where did I put it? Oh, here it is. Here is, if it will come up. Come on, internet connection. Okay, so yeah, so this is my sort of landing page for all my class websites. So for this term, this course, click there on Math 212. This is the class website. Okay, so your assignment for today, so here's your first day reading assignment, is to read everything that's on the main page. Read all of the links in the course information section. So let me go back over there. That's these 3 links down here. General policies, general comments, exams, homework, and grading. There's a lot of stuff on those pages, and I want y'all to read all that stuff. Let me just show you. This one here is enormous, by the way, general comments. This has grown over the years. It started off with, a couple of bits of advice I wanted to offer to students, getting started in my classes. I think you'll find this useful. Here's a suggestion, that kind of thing. And then as I taught more and more students were coming into my classes with the wrong sort of philosophy or, misunderstandings, bad assumptions about how things were going to go or what was a good idea, what's a good way to learn math. And so it has slowly grown and grown and grown and grown and grown and grown. So I do want you to read all this stuff. I put it all on here because there have been situations. For each one of these entries, there's been a situation where I found that there were students who really did not understand this and it affected them negatively. So it's all important to read. That's just the general comments page. There's also a whole thing about exams and grading and how all that stuff works, another huge file. So this is a significant reading assignment. I know, likewise, the general policies page. Significant reading assignment, but it's just, I think it's really important to do all that stuff. And by the way, please take it all literally and seriously. This is all, you're gonna find that Duke is a very different experience from your high school, especially if you went to a high school like I did. But even if you went to a superstar high school, Duke is still going to ratchet it up a notch. I think you'll find. Okay. Also, I think it's a good idea to click around on all the links scattered throughout these pages. Just you don't have to memorize everything on every link on every one of these pages, right? It's not realistic. But at least kind of know what's there. Right? Okay. You'll find the syllabus linked from the class web page. The syllabus shows all the sections of the book we're going to cover, all the homework assignment questions for each of those sections. The lecture schedule, I'm actually going to go over to that one. Let's see here. Here we go. Lecture schedule right there. And this shows approximately where we're going to be in the course at every day of the semester. So you'll note certain key things are here on the lecture schedule. The exam dates are there. Right, exam 1, exam 2, exam 3. Holidays, Thanksgiving break, no classes. Right? Fall break. Most of these entries, of course, show a number. This indicates what page of my lecture notes I expect that will be through, hopefully, by that day. So on, my hope, if we can keep up the 7 or 8 pages a day pace that I've found, works with the way I've written my lecture notes, then hopefully on October 17th, we will finish page 152. Right. Okay. So let's see here. You're going to find those lecture notes on Sakai, also linked right here from the page. Let's see here. Duke Sakai login. Oh, come on. I just did this. Sorry?
Relatable.
Yeah. It's like every 10 seconds, it seems like. Yeah, no, that's right. It's a real pain. So let's see. On the Duke, let's see here. Math 212, Section 7. Here it is. Okay, so I haven't done anything with this site yet. And very soon, haven't done this yet. Shame on me. I will be adding some files into this resources section. So, by the way, you're all familiar with Sakai? Have you all used Sakai before? Some yes, some no. Okay, Sakai is how it's Duke's learning management system, they call it, or classroom management system, depending on who you talk to. And the idea, I can put a file on Sakai, and any student enrolled in the course can access it, and nobody else can access it. So some things I put on Sakai. Some things I just put on my web page. I don't really care if someone is able to track down our class schedule. I don't really care, right? But anyway, some things I'll put on Sakai. Grades, depending on this, that, and the other thing, some grades will go on Sakai. So I can click on Gradebook. There are no graded items in here yet, of course, first day of class. But some graded items will appear here, and then when you log in to Sakai, you will be able to see your grade and only your grade, and not anyone else's grade. I'll be able to see I can enter all of them, see all of them, and then you can only see the ones for your account. So it's pretty neato. Anyway, so that's where it is. Let's see, where was I? I think I was here. Yeah. Okay. So there's lots of stuff to see there on the class website. Don't forget, reading assignment. Some resources I want to talk about. Forgive me for the cheesiness, but I like to always list yourself as your own primary resource. This is just a reminder that you have to take the initiative, right? In a lot of high schools, they kind of do what we call hand-holding, right? And they make you do the homeworks, right? They give you multiple chances to do this, that, and the other thing, right? And in some sense, unless you're just really dedicated to falling behind, they make it where you kind of can't fall behind. So we're not really going to do that in Math 212. I don't know. I can't speak for other departments, but in math classes, pretty much, we're going to present the material. We are going to have due dates. We're going to give you a schedule, right? But then it's kind of on you to make sure that you're learning the material, right? Make sure that you're really absorbing it. If you kind of decide, I think I'm going to procrastinate and I'll study math later, I'll do that next week, right? I'm not going to track you down in your dorm and set you straight, right? So you've got to take on some real responsibility here. Math 212 comes at you really, really fast. So you've got to make sure that you keep up with the progress of the material, the progress of the course. Otherwise, you fall behind. So again, that's your job as a student. And again, very different from high school. Okay. The next resource, the book and the lecture notes. By the way, just a preview. Here's what my lecture notes look like. It's all handwritten, and then I scan it and make a PDF file out of it. So we're going to go through and start doing math as soon as I finish all this introductory stuff. So y'all are going to have a copy of these notes. And one thing you might want to do, conceivably, print them out, bring them to class, and annotate with your own writing on top of that. So, or not, right? Suit yourself. Do whatever you want with these notes. If you are the kind of person who just has got to write it down, if you don't write it down, then it's like you never heard it in the first place. Okay, hey, suit yourself, right? But I'm going to be using these in class like this, and I would have found it very convenient when I was an undergrad to have everything that was on the board also right there in front of me, so that I didn't have to constantly transcribe. I made a decision at the start of my junior year in college that I am not taking notes anymore, because I found that I was the instructor was up there writing chalk on the board as fast as he could. In order to keep up, I was writing with a pencil and paper as fast as I could, and when we were done, he'd said a bunch of words. I hadn't heard any of them because I was busy transcribing, and I had all the notes. I hadn't the slightest idea what happened, right? So all of the ideas just right over my head, right? And I decided that doesn't make any sense, right? And so I put my pencil down and I folded my arms and I got comfortable and I started listening. I found that it really helped. And that's just me. Anyway, you can fold your arms, sit back and listen, and still have the notes. So, all right. Okay. Yeah, so having these things, and in fact having them in advance. And by the way, the book is not bad. It's not my favorite book. I have quibbles with the book in various places. I'll comment on those, trying to be as polite as I can as that happens. But it's overall, it's not a bad book. It's a good book. I think you'll find it to be a useful resource as well. I encourage you to read both of these before you come to class. Then, of course, come to class. Mm-hmm. And then after that, read them again after class. So that's 3 passes through the material. Your first pass through the material, reading it before class, I do not expect you will understand everything. Of course not. That'd be ridiculous. If I could expect you to understand it upon reading, we wouldn't have class, right? What would be the point? So, but I want you to kind of, start to see, roughly what's about to happen. Where are we going with this? What are the questions we're interested in? What's approximately the approach that we're going to take? And then form some questions in your mind as well. There's this whole bit here of I just don't see what the purpose of that is. Right? Then when you come to class, some of the ideas I'll be talking about you'll already get, and you don't have to waste class time thinking about that. You can then spend that class time thinking about other things that you hadn't gotten yet, right? You'll have these questions in your mind already formed. You can think about how is Bray addressing these questions, etc. And then, now, after class is over, the moment y'all walk out of class, I still don't expect you to understand everything at that time. I know 50 minutes is a long time when, math is coming at you real fast. Right? Yeah.
Are you going to go through the textbook in a linear fashion?
No. We're going to be bouncing around a little bit.
Okay.
Yeah.
There's the schedule on the...
Well, my lecture notes, there's 275 pages of lecture notes, and I'm going to go in the same order that my lecture notes are. Yeah. So I haven't charted that to exactly which sections we cover when, but you'll notice. Yeah, totally. Okay, so I don't, again, right after class is over, I don't expect that in class time you will just walk out 100% solid on everything. So read it all again after class. I think 3 coats, right, is a really good way. And by the way, after class might be multiple readings. Multiple passes through. So at least 3 coats, I'll say. I think is a good approach to learning ideas. By the way, furthermore, another motivation for reading the book, reading the notes, is I'm not going to cover everything in class. There's not enough time. It's not realistic. There are examples in the book that I think are perfectly well treated, perfectly readable, digestible. After you've come to class, I think you can just read those examples and you don't need me to walk you through them. So I won't do those in class, right? There will even be some days that I will skip entire pages of my own notes because this stuff is pretty straightforward. I think you guys, I think our time is better spent focusing on something harder than, me spending class time on this material over here that's pretty straightforward that you could just read. Yeah.
Will your notes cover everything that we need though?
No. So the book, the notes, and class time, and it's a whole Venn diagram, and you're responsible for all of the whole thing. Yeah, right. Absolutely. Okay. Yeah. So, okay, resource number 3. Note how far I am down the list. Right. So I hope I can be useful to you. I mean, that's why I'm here. Right. Obviously, if you're going to get any good out of me, you do have to come to class. Right. So attendance is important. By the way, I'll remind you, we're recording. I'll be recording every lecture throughout the term, barring technical glitches or difficulties. When I first started doing this, my class attendance took a nosedive. You can guess why, right? It's being recorded. I don't feel like walking all the way over to the physics building right now. I'll watch it later. And based on how midterm exams went that term, I think they did not watch it later. So students can get themselves into big trouble that way. I think it's a bad idea. So class attendance is required. Plus, we're not the University of Phoenix. Right? This is an on-campus, present, interactive university, so we need to make sure everybody's here. So, by the way, side note, I will be taking attendance, not today, but starting after the class roster settles down, which should be early next week, I will start taking attendance. It's also a good way for me to learn your names. Right now, I know none of your names. I'm sorry. I will. Give me time. So attendance does count as part of your grade. It's not a whole lot. It's one of these deals where everyone's attendance tends to be pretty good, and so even though it counts for, over the semester, attendance counts to something about half of a midterm, right? But the thing is, everybody has good attendance, which means it effectively doesn't count very much at all because everyone's going to have good scores. So it's a nice system. It's no one's going to pass this class on the basis of standout stellar attendance. There is no such thing, right? That said, if you don't attend, if you skip the entire semester, then you will be way down. All the other scores are up here, you're down here, and that does make a big difference. Okay, so everything works out. I'm a big believer in group work. I did a lot of this in college. Physics classes, especially for me, math comes more naturally to me. Physics, I really had to work. And so we had study groups. We would get together and work on the homework together and trade ideas. And if I got stuck, he'd help me. And if he got stuck, I'd help him, etc. And it's really super helpful. I think in those classes, honestly, I think I learned more physics from my classmates than from my instructors, as it turned out. So I'm a big believer. I want to encourage y'all to do that. Self-organize, right? Take the initiative, meet some people, and I think it's a big win. Obviously, when I say do the homework in groups, don't take the homework and cut it into fifths and then trade and copy. This is clearly, obviously, not what I'm talking about, right? That's obviously not a good learning method. Right? So what you can do, though, is, instead of, I can't get number 12, here, let me copy from yours, it's, I can't get number 12, can you help me understand it? Have a conversation, come to understand it, and then, oh, great, thank you. Put that paper away, you take your clean sheet of paper and pencil, and then you write it up directly out of your brain, right? Not transcribing from someone else, right? But comprehension to paper in your own words, in your own, work. Does that make sense to everybody? Okay, let's talk a little bit about expectation. What I expect of y'all in this course. Again, this is, I feel this is all stuff that has to get said because it's pretty significantly different. Yeah.
Is there a help room for this?
There is. The help room, is that not on the resources? Oh, it's not on my resources. Help room is a great one. Maybe that's it's kind of sort of both of these, isn't it? So the help room. Yeah, so the help room is open Sunday, Tuesday, and Wednesday nights. In fact, there's a link to it on the web page. Let's go back to the web page here. Where was my web page? I guess I don't remember. Here we go. So here's the web page, and right here, there's a link to help room. Click right there. We go to the math department's page, which is loading slowly, but anyway, it's here. Oh, it didn't load correctly. Come on. There we go. Here's the help room page. And this is the Math 202 and 212 page. You can see who's going to be there on which nights. Yep. 7 to 10 p.m. those nights. 137 car. Good resource to know about, by all means. Okay. There's also a peer tutoring thing. I'll go ahead and plug that while we're here. Peer tutoring program is sponsored by the Academic Resource Center. They take people who have done well in the course in the past. Some of them are even math majors. The peer tutoring program pays them for you, so you get free tutoring, right, from someone who's done well in the course previously. And they have certain rules. They only have so many tutors. You have to get first come, first served. You can only get so many hour-long meetings with these people. But anyway, nevertheless, it's a really good resource. And by the way, because it is first come, first served, maybe go ahead and get one. If you think there's a reasonable chance you're going to need one, go ahead and click over here and get that peer tutor. Okay. All right. Okay, let's talk about expectations. In my high school, let me not speak for your high school. In my high school, it was pretty much a matter of memorize certain facts and execute certain algorithms. And that's pretty much what math was. You had to know which algorithm to apply in which circumstance, right? But, nevertheless, it was highly algorithmic and rote. Okay. So that's step one for us. That's absolutely not all you have to do in this class. Again, this is Duke. So we expect you to actually understand what it all means, where it all comes from, right? Why does this algorithm work? Under what conditions does it work, right? What do you need to assume in order for everything to actually go through meaningfully, right? So these are ideas of really understanding the ideas. So that is a requirement. That's part of what we want you to get out of this, and we will be testing it. Right? My high school didn't do that at all. One of the big ways that we test it is level number 3 of proficiency that we want you to get is I'm going to put questions on the test. I'm telling you right now, questions on the test that you have not seen before. Right now, with a high school level of understanding, what are you going to possibly do with this? Right? What you're going to do here is you're going to take this understanding that you have, right, and you're going to look at this question that you've never addressed before. This is an application about some physical scenario that we never did anything like this. And you'll say, well, look, it's not exactly like anything we did in class, but this is an idea that we can break down in the same way. I can take the ideas that I understand and I can kind of overlay them over this particular scenario in a similar way, and now I've got to kind of think through how these ideas overlay on this circumstance, but basically apply comprehension of ideas to come up with your own solution for how to deal with this unfamiliar situation. So don't say I didn't warn you. Right? So that's absolutely going to be there. It's on purpose. Despite this warning that I give every semester, Course evaluations at the end of the semester routinely say, this class was not fair. There were questions on the exam that we had not previously been shown how to do. Like, well, I know this. That's on purpose. So anyway, that's one of these things to take seriously. Okay. So I want to talk now about, why do we make you do that? Why do we make you jump through these hoops and understand these things and, test whether you can apply ideas in unfamiliar situations? I don't know if y'all are familiar with this thing called Wolfram Alpha. Some of y'all are, I guess. Okay. For those of you who are not familiar, let me show you what Wolfram Alpha can do. Here we go. So you can see what I typed in here. I went ahead and did it because, again, my internet's been sketchy, and so I wanted to make sure it was already here. But look what I typed in. I didn't even type in code, right? This is kind of English language, how people talk, right? I typed in integrate the reciprocal of 1 plus sine x. And look what it spat out as a result. Wolfram Alpha will crank out algorithms wonderfully, right? So here's, why do I bring this up? I'd like to address the question, with this in mind, why can't I just memorize algorithms, right? Why can't we just, do this, leave it at that? I know certain facts. I can crank out certain algorithms. The reason, among other things, is that if that's all you can do in math, is crank out algorithms, right? Then mathematically speaking, from the perspective of a company that might be interested in hiring you, a graduate program might be interested in admitting you, you are just a slow, expensive, and unreliable alternative to a free program. I'm just saying, right? I mean, it's a little harsh, I know, right? But the point is, that's what the world's become. Here's an interesting thing you can do sometimes. Find some old textbook on math. I stumbled across an old trig textbook from the 1950s, I think it was. And something like half of it was how to compute the values of the trig functions. How to use trig tables and how to, use the symmetries of the trig functions. And, if you need to compute cosine of some angle, you could just compute sine of pi over 2 minus that angle. And, computational ideas like this, half-angle formulas, how to do the arithmetic. Well, then the calculator came along, right? And those skills become, I don't want to say useless. There are ideas underlying those skills, but certainly the value of being really good at computing the values of trig functions becomes just not so useful anymore, right? The world changes and education has to change accordingly. So memorizing algorithms is, being really good at executing algorithms. It's still useful. You still have to be able to do those things. It's just not enough anymore, right? Does everybody see the big idea there? I like this Wolfram Alpha connection because I think it's very dramatic. Right? I don't mean to scare you or anything, but nevertheless, it makes a good point. Okay, here's another idea along those same lines. So that the similar question that we get sometimes is, look, just show me what I need to know. All right. What objects am I going to need to be able to deal with? Just show me those, and then we can call it a day. Right? Well, I don't really know what you're going to be dealing with. Right? I know a little bit about applications in some fields. I know some of what econ does, some of what engineering does, some of what physics does. But I'm not an expert in those fields. But more importantly, you are not working in those fields right now. You are possibly going to be working in those fields in 5 years and longer, right? 10 years, you'll still be doing something in some field that apparently, given your presence, has something to do with multivariable calculus, right? So I don't know what questions you're going to be dealing with. I can't just tell you what you're going to need because I don't know what that is. Right? So this is why we do the best we can. Obviously, we are going to show you examples and applications, but this is where the understanding comes in, right? That, I want you to understand where these ideas came from, because when you get around to, 10 years from now working on some application, The ideas we've shown you might not be the right ones, but you can take the ideas you do understand, realize that the circumstance you're up against it's kind of like that idea, but it's not the same as that idea. You can adapt that idea to your circumstance. Well, if you don't understand the ideas behind what I show you here, then you can't adapt them. Right? So it's kind of similar to this business right here. Okay. So along these lines, ideas, process, clarity, these are evidence of comprehension. Right? Really getting the ideas. You're getting what we need you to get out of this class. So that's far more important than whether you get the right numerical result at the end of a homework exercise or at the end of an exam question. Right? So that's how we grade. If we're truly going to claim that we're going to test understanding, we have to grade based on how much do we see that you have demonstrated understanding and proficiency. So again, I'm telling you this right here. I mean, it has happened on many occasions that students will get the right numerical result as a result of making completely inappropriate assumptions, ignoring serious complications in the problem. That ended up not actually changing anything, but that could have, right? Or canceling sign errors, right? This kind of thing. So you could even get the absolutely 100% numerically correct result and not get all the points for the question. And depending on the circumstance, depending on how bad it was, you might get none of the points for the question, right? So being a course about ideas, just keep in mind, you got to show your work. Show your process. Not because I don't trust you, but because that's what I'm going to be grading on, not the number at the end, right? Communicate your ideas clearly. If you understand something clearly, you can explain it clearly. If your explanation of something is contorted and awkward and backwards, this is evidence of muddled understanding, right? So I mean, we are going to be grading for clarity. So, common situation, students are learning math. They get to the point where they're like, okay, I think I can do those. Okay, that's nice. It's good to be able to do the questions, but you do need to understand more than that, right? You have to understand how to explain the ideas. You have to understand how, why it is and that you can do them, right? And be able to clearly explain so that we know that you really understand what you're doing. Okay. All right. Similarly, exams are not just like the homework. Well, again, of course, right? I mean, if the exams were just like the homework, then we wouldn't be testing these things. Okay. So, I mean, this bit. All right. This is an awkward topic here. This business. But comprehension, I think it's important to understand. It's just not a binary thing. Anyway, I believe it's not a binary thing. My understanding myself of certain big math ideas has clearly grown and deepened over years, right? So it's not a matter of, oh, I get it now. Oh, I didn't get it before. Oh, but I get it now. It's not this binary light switch kind of a deal. So comprehension is a spectrum, right? So the reason I bring this up is because of this little nasty reality, and that is that the bar is higher at Duke. Again, this is probably not terribly surprising, right? So this non-binary, this continuum of comprehension tends to come off as binary as a result of the following. High schools implicitly set a bar. As you study something, even though you don't feel like you get it, I mean, you are in fact learning more and more until you get up to a certain point, and y'all have kind of honed in over your high school careers that, when you get to a right around in here, when you get to an understanding of that level, you're like, oh, okay, you know what? All right, I'm good. I understand this. You know how hard your tests are going to be on your high school test. You know that they're going to be at this level. My understanding's at this level. Okay, I think I'm good on this. Right? Okay. So, y'all have this bar set in your mind. Now, I can't tell you where that bar is, and you can't tell me where that bar is, because this, the comprehension axis doesn't have units. There are no metric units of comprehension. Right? So we can't make any of this precise, but implicitly on some level you've got this bar in your mind of what it means to understand. Where is the level that is understanding? Okay, so here's the thing. Duke's level is here, right? So if you learn up to the point where you're accustomed to learning, and you're thinking, oh, hey, cool, I'm ready for this exam, and yeah, maybe you are ready for this exam, but you are not ready for this exam. Everybody see the difference? Right? This is a nasty little problem, again, because I can't make any of this quantitative. I can't say, 17.6 metric units of comprehension is where we set the bar. It doesn't mean anything, right? So anyway, be aware of this phenomenon. Be aware that, you have in your mind this just based on experience, this idea of, what's good enough in understanding something, and keep in mind that this can lead you terribly astray, right? You are going to have to take a test at that higher bar. Okay, so how do you know when you're there? If we can't quantify this, how do you know when you're there? I don't have any perfect answers to this question. I'll give you two answers that are kind of, they're worth something, but they're not perfect. First answer, all of my old solutions. You go to the math part, or go to the my web page, scroll down here, and you see exams and solutions. This is every exam and every solution that I've written in this course since 2004. So this goes way back. And you can look at some of these solutions. So here's an old exam and a question and my solution. Right? And so this will give you just a bunch of reference points of what kinds of level of difficulty of questions do I expect you to be able to address, and what kinds of, what level of clarity and rigor and depth I expect you to be able to go into in your answers. So it's just a bunch of data points, and whatever that might be worth. Okay, so there's that. Here's the other one that I have. Let's see, where am I? I think I'm here. Yeah. Okay. I made this one up a few years ago, but I think it's pretty good. It's a little head game that you can play with yourself. I think it's very effective. So ask yourself, how would you feel, and try to really throw yourself into the plausibility of this. How would you feel if you had to come up to the board and spend 15 minutes talking about that particular topic, whatever it might be, in front of the class? All right. Now, as one example of how this method works, I'm going to be talking about Math 212 in front of the class, and I'm not scared at all because I'm good at this stuff, right? So this is consistent with the fact that I have expertise on something, hopefully, and so I'm not that afraid of it, right? But if one of y'all had to come up to the class and give a lecture, 15 minutes, that's a long time, right? You have to fill a lot of otherwise dead air, come with a bunch of ideas, all organized in the right order. This is a pretty tall challenge, right? So ask yourself that question, after, for some given topic, and since we haven't covered any math yet, just think back to some Calc 2 topic that you covered in high school, the integral test, right? If you had to spend 15 minutes presenting the integral test, is that a scary prospect? I assume that it is, right? Should be a scary prospect, I think, if you imagine, all right, here you go, here's the stylus, go. Blank page, you've got 15 minutes. Should be a little bit scary, right? Well, the better you know something, the more of a death grip you have on an idea, the more it's just not that scary, right? So some topic that you are, really, really awesome at, there's always a little bit of a fear of public speaking, right? Factor that out best you can. But if you had to give a 15-minute talk on, let me think what would be a good example. Basic, Algebra 1 techniques to a class of Algebra 1 students. That's not going to freak you out that much, right? Because I assume y'all are all really good at that. Okay. So anyway, I think this is an interesting way of getting inside of your own head. If you want to know how well am I just lying to myself? Am I at this level, and I'm just kind of lying to myself about, having real understanding, or am I just solid on all of this? Play that little game. Ask yourself, hypothetical scenario, 15 minutes, blank board. How scary would that be? That's it. Anyway, I like this as a tool. It's a way of getting inside of your own head and sort of forcing yourself to be honest with yourself. It's just a concept. You don't have to actually do it, right? But anyway, for your consideration. Okay, I know y'all already know that. The rumors are all over the campus, right? This is a hard class. It's a hard class to teach just because there's so much material that we have to cover. If I were to spend as much time as I would really like, just talk about every given topic in this class until I felt like, okay, I don't really think I have that much more to say about it. I think I'm comfortable with, let's move on to the next thing. I'd probably only get through about 3/4 of this class. So it's constantly pushing, and we're just got to go as fast as we can. And furthermore, it accelerates throughout the term, right? So if you set your idea of how much time you're going to study in Math 212 based on your experience of the first 2 weeks, well, that's really not going to cut it for the last 2 weeks of the class, right? It definitely kind of does this sort of steadily throughout the term. So anyway, make sure to give yourself plenty of room in your schedule. I'm a big believer in time management. I encourage you to have your, how are you spending your week pretty much already planned out. How much time am I dedicated? Here are the graded items that are due on any given day, and here are where my tests are. When am I studying? When am I doing the homework? When am I writing that essay for that history class? Have it all planned out so that you don't find yourself unexpectedly, oh my gosh, I've got a test tomorrow, a paper to write, and a homework set for Math 212 that I guess I'm just not going to be able to get around to, right? Okay. All right. Okay, yeah, we've already talked about the lecture recordings. I say might because I every so often have technical difficulties. Any situation where a recording does not go through, here's the good news. I've been doing these recordings for some time now, and I have lecture recordings from previous semesters. And I will point you all toward where you can find, a probably roughly equivalent recording. So I feel pretty confident that I should be able to give you some sort of recording for everything that we do in this class, and most of it, fingers crossed, will be recordings of what we actually talk about. How to use this? I think it's a great tool for studying throughout the course. Right? I think so. So, for example, after class is over, and we're going to get to the math really soon, I promise. After we do a certain amount of math, again, you don't really quite get it. There were things that happened that you didn't understand. You go through and you read the book. That helps a little bit. There's still some things that you don't understand. Having read through something, having kicked it around with some friends or worked out some attempts on your own, you might find that if you just go back and listen to it again, it might all of a sudden make better sense. Right? So I like this idea of sort of the back and forth. You watch video recordings. You get up to a certain point. Well, then the book and the notes will help you get a little further. That extra little bit of understanding there will help you get further in the lecture in the lecture recordings, and then just again, like that. So, I think they're a great study tool. I encourage you to make big use of them. Likewise, before exams, if there's some topic that's just been gnawing at you and plaguing you, that you just he spent all this time talking about some particular topic that you just didn't get, and it's come up and you still haven't gotten around to filling in that gap. Before an exam, by all means, go back and watch that recording again, right? And solidify that bit. While you're doing a homework assignment, it may be that there's a homework question that's pretty directly addressed by something I did in the lectures. Well, go back and, watch that portion of the recording. By the way, this is all on a YouTube channel. Maybe while I'm here, I'll go ahead and point to that. So, here we go. Lecture recordings. Whoops. That was supposed to. Okay, well, anyway, lecture recordings. You can see it right there. And you click here. I'm not going to click on this because it'll go to my YouTube channel and start playing the little introductory video. I don't want to do that. But click right there, and it'll take you right to it. You may want to subscribe for convenient access to that channel and all those recordings. Okay. Yeah, so attendance. This business about attendance codes and attendance quizzes is part of how I do attendance in my large lecture class. So it has nothing to do with us. Here, I'll be taking attendance just the old-fashioned way. At the start of the semester, I'll be calling names, and you got to say something, raise your hand, let me visually identify that you're here, and I'll check you off on the list. By the end of the semester, I hope to just be able to visually go through and see if everybody's here. Okay. It does count toward your grade. Again, enough that it would be a big penalty if you regularly skip class, but not enough for little, 1 day's attendance here or there is not going to make much of a difference at all. Okay. All right. Very last thing, and then we'll do just a little bit of math before we go on. This is ultra low tech. Y'all may have better solutions to this at this point than I do, but if you are interested in finding someone to work with and you don't know anyone that is in this class, you can send me an email and ask me to add you to the study group email list. The study group email list, all I will do is maintain the list. I'll make sure that everyone on the list has contact information for everyone else on the list. I'm out. I don't pair people up or group people up or set times. All I do is just share email addresses. The nice thing about this is only people who have also asked to join this list will get your information. So it's a confidential way of finding some people to work with. So anyway, if you're interested in that, drop me an email. I'll add you to the list. Okay. I think that's everything else is summer. Okay. Cool. So let's do some math. This first example is not Math 212. This first example is just an example that I use to help students understand what I mean by understanding ideas and adapting ideas. So here's the question. It's a hypothetical little brain bender kind of a puzzle. So you have an 8 by 8 array of squares like so. You have a supply of 2 by 1 tiles like this, right? That of course you can arrange each of 2 different ways. And obviously if you have 32 tiles, you can cover all 64 squares. That's not the brain bender. Here's the brain bender. Suppose you remove the 2 opposite corners. Just cut them out with a pair of scissors. And I also take away one of your tiles. Now you have 62 squares to cover 31 tiles. From an area point of view, it seems possible. Right? There's no obvious contradiction involving area. But just because there's no area contradiction doesn't mean you can actually do it. So, can you actually do it? And everyone's always approaches this question by doing this. And just, okay, let's just start doing it. Okay, now this square here, having put that tile like that, there's only one way for me to get at this square, so I have to do that. And then, okay, so let me start doing this now. And you kind of feel like you've noticed the pattern and that, okay, we just sort of keep going. Except the problem will be that at the end, you will find yourself with, for example, these 2 squares left over and 1 tile, and of course, you cannot cover those 2 squares with 1 tile. And so you think, okay, I made a goofy mistake. I painted myself into a corner in a pointlessly, unstrategically. Let me undo that problem. I'll go in and fill in that part, and then it'll probably all work out. And what you'll find is that no matter what you do, You keep painting yourself into a corner. All right. So this is a hard question, actually. Can you actually cover the remaining board with the remaining tiles? Then you think, okay, I'm going to code it up in a computer. Well, it is going to be kind of a pain to code this, right? And it's going to require the computer to go through billions of scenarios. There's 31 tiles. Each of 31 tiles can go each of two different ways. 2 to the power of 31 is more than 2 billion. Right? You think, okay, computers are fast. That's true. What if instead of an 8 by 8 board, what if it was a 50 by 50 board and a corresponding number of tiles? There would be unthinkably, like trillions times trillions times unimaginably large, the fastest computer known to man, if it had been working for the entire known history of the universe, could not try that many scenarios. Right? So, nasty problem, and computer approach is a poor solution. Okay. All right. So, here's the creative solution. Make a checkerboard pattern. And let's see, so I'm going to use, let's see, how am I going to do this? I'll use, okay, so we'll apply a checkerboard pattern. So, y'all know what checkerboard pattern is. I hope it's every other sort of, diagonally kind of pattern there. And all I've done is pull out a can of paint, right? I didn't really do anything there. But I apply this checkerboard pattern, and having done that, let me observe that, oh, hey, every time I put down a tile now, I cover exactly one red, exactly one white. Oh, wait a second, I was using black and white in the, okay, for whatever. So one black and one white, okay, fine. Yeah. So, the difference between the number of black tiles covered and the number of white tiles covered, when I'm putting down these dominoes, always 0. I don't care which of the trillions, quadrillions of different versions of how to cover, to attempt to cover with tiles you might choose to do, the number of black minus the number of white covered, always 0. The 2 tiles that we removed, however, were the same color. I don't know if maybe they're both white, maybe they're both black. It doesn't matter. The point is, the number, what I need this formula here, this thing I that cannot ever change from 0, I'm going to need it to either equal to 2 or negative 2. I don't know which one, but it's got to be one or the other. And there's no scenario in which 0 is equal to either of those numbers. Therefore, this is not possible. Yeah? Everybody see the argument? Super clever? Much better than coding? Much better than waiting the entire length of the known history of the universe? Okay, all right. So this is what I like to call a creative solution for a couple of reasons. For one thing, the pattern that we applied to the board, that was not part of the question. We made that up. We created that idea of applying that checkerboard pattern. It is literally creative. A lot of people mistakenly think that creativity only applies to stuff like art. This is absolutely false. This is truly, literally a creative solution to this problem. There's a lot of creativity in mathematics, by the way. This is an easy example. By the way, this formula here, this I thing up here, that was not given as in the statement of the problem. That is something we created. Right? So this is doubly creative solution. And I also like to point out that this idea, this number I, this formula for I, this is an example of a very commonly used mathematical strategy called creating something called an invariant. Invariants are really, really useful ideas. There are many instances in math where what we do is we say, look, there's a lot of possibilities going on, a lot of different ways to do this, but notice that all of these different scenarios, they all have this one thing in common. Lots of other things may change, but this is an invariant construction here, right? And if you can create an invariant for your problem, you've got the potential to draw powerful conclusions. So, big idea in math. Kind of a cultural point. Okay, all right. Now, thus ends the two-page discussion on checkerboards and dominoes. This is not Math 212 material. Why am I wasting your time with checkerboards and dominoes, aside from the fact that it's cute? And this gives me a nice example of how to talk about what I mean by really understanding an idea. Right. So let's talk about hypothetical test questions. Here is a test question that I might conceivably ask, which is I might face you with an 8x8 array with opposite corners removed and ask you if you can cover it with the appropriate number of dominoes. And I hope you would find that to be an easy question on the test, because that's what we just got through talking about. Right? So this is the high school level of an exam. I'm asking you to convince me that you can reproduce what I've already told you. Right? So that's sort of memorize, regurgitate, execute the algorithm level of question. All right. Okay, a slightly harder question. A 20 by 20 board. This is scary. A 750 by 750 board. Right, where again you remove opposite corners, appropriate number of dominoes. That'd be a slightly different test question. Still pretty easy. Same idea. Right? But the point is, you'd have to apply that idea to a slightly different situation. Now here's where the eyebrows get raised. What if it's not square? What if it's 10 by 20? Ooh. Scary. Now what you've got to do is adapt the idea. You've got to look back at the argument that we made. Okay, he said make a checkerboard pattern. Can you put a checkerboard pattern on a non-square array? Yeah, sure. Right? That part of the argument works. Do dominoes still cover exactly one of... Yep. And just go through all the individual steps of the argument and ask, does it still fit in there? So 10 by 20. By the way, everything works. So the answer to this is, it's the same... Well, so technically the answer was no. Okay, so the answer continues to be no for all of these. And then here's the next question. What if it's 75 by 150? And you think, okay, well yeah. So look, non-rectangular, same story. Come on, the argument's going to still work, right? It doesn't. Whoa, right? So why doesn't it work? I thought we agreed that this works for rectangles. 75 is odd. That's right. So the purpose of this example is to point out that just because a question involves some of the same objects as an example that you've seen, that does not mean that the argument still goes through. You've got to look at the argument and see, okay, the argument requires several things to be true. I have to be able to apply a checkerboard pattern. I have to be able to cover one of each color with the dominoes, blah, blah, blah. I also need the squares that I have removed to be the same color. Right? In this 75 by 150 scenario, no matter which two opposite corners you remove, they will always be different colors. So your invariant that unavoidably will be 0, the checkerboard argument, the domino argument, the invariant argument, I'll call it, says, well, but if there is a solution, that invariant would have to be 0. That's not a contradiction. It is 0. It has to be something which it unavoidably must be. There's no conclusion to be drawn there. Yeah? Everybody see the idea? So what has happened here is our solution has gone out the window. So now you're faced with the harder problem of, well, can I come up with a different argument to show that this board cannot be covered? Or maybe let's admit that in the absence of a disallowing counterexample, maybe this board can be covered with dominoes. So you got to consider that possibility as well, right? Okay, so these questions get increasingly challenging as you go down the list here. What if you remove non-opposite corners? Well, again, the invariant argument fails. It draws no conclusion. What if you don't necessarily remove corners? What if you remove I'm not even going to tell you which ones. If I remove unspecified squares of different color, right? If they were the same color, again, the invariant argument crushes it. But if they're of different color, can you address this problem, right? Can you or can you not cover this board? So this is quite a hard problem. And if you're up for it, by the way, these are all questions that you can toy with. I think they're all, fun questions. But this one here is really quite challenging. So if you're up for a challenge, think about this one and come talk to me afterwards, after class or Wednesday or whatever, and I'll tell you the answer. But what if it was with 3x1 tiles and you're removing 3 corners? That's a hard question. Okay. Anyway, I just wanted to point out that, again, there's this sort of gradient of, what do we mean by understanding? And I gave you this 2-page lecture about invariants and checkerboard patterns and dominoes, and this is a discussion of ideas. I might ask you to reproduce those ideas, but I also might ask you to make slight adaptations to these ideas, and I also might, just to check and see, who's regurgitating when they feel like they're supposed to be, who's telling me what they think I want to hear, by putting in a landmine that you're supposed to notice, right? Because you've got to think through the arguments and ideas. Okay. All right. So this is about where I typically end first day of class. I'm sorry, looks like I went a little 2 minutes over. So we'll call it a day. We'll pick up here with some actual Math 212 material on Wednesday. Welcome to Duke. Hope everybody's